Okay, for question 1, the question asks you to predict two possible isomers of compound B. This is the compound B, and you need to give two possible isomer. So basically, when we see question like this, always remember in your mind, normally when the question asks you to give two possible isomer, normally it will be related to constitutional isomer. Do you still remember what is constitutional isomer? Constitutional isomer is isomer that have a same molecular formula but different arrangement of carbon in the structure. So how many carbon in the structure? 1, 2, 3, 4, 5, 6. 6. So C6H. Here is 3, 3, 2, 3, 2 is 5, 5, 1, 3 tambah 2, 5, 5 tambah 1, 6, 6. Here is 2, you get 8, 8 plus 3 equal to 11, 11. Then after that 11 plus 3 equal to 4, 14. So the formula is CnH2n plus 2. So you double check if the n is 6. 6 times 2 is 12, 12 plus 2, 14. So C6H14. So the arrangement, so the two possible isomer should be straight chain 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. Or you reduce the number of carbon in the straight chain 1, 2, 3, 4. 1, 2, 3, 4, 5. And maybe you can change the location of the substituent. Here the location of the substituent is at carbon number 3. Maybe you can put at carbon number 1. So in order to check is it your constitutional isomer that you suggest is correct or not, you can give a name to this isomer. If the name is different to each other, so your answer is correct. 1, 2, 3, 1, 2, 3, 4, 5, 6. So the answer is hexane here, and here is 1, 2, 3, 4, 5. 1, 2, 2 methyl pentane. So and for the question B, predict the balanced chemical equation for the complete combustion of compound B. When we talk about a complete combustion, always remember in your mind, it will produce CO2 plus H2O. So plus O2. So the answer should be CO2 plus H2O. So if you want to write back the formula, okay, C6H14 plus O2, CO2 plus H2O. So here the number of carbon here is 6, so you put here 6 in order to balance the stoichiometry. Here you can put Maybe we try to put 7 because hydrogen is 14 here, so here it should be 14. And for the number of carbon should be here, a number of, not carbon, oxygen. Number of oxygen is 12. 6 times 2 is 12. 12 plus 7 is 19. Okay, so C6 here is C6, hydrogen is 14. 7 times 2 you get 14. Then for oxygen, 6 times 2 is 12. Here is 7, so total up 19. So here is 19 over 2 times oxygen. So basically you can put like this. So basically if you cancel, you still get 19. You can put 19 over 2 oxygen like this. After that, for question C, identify and indicate the major and minor products formed if compound B undergo chlorination reaction. So the question asks you to provide major and minor when it goes undergo chlorination. Normally this is a reaction of alkane, which is referring to radical hydrogenation substitution. Cl2 in the presence of UV light. So the answer should be N plus major and minor. Here is major, here is minor. How do I know the structure of the answer? Because before this you learn when you have straight chain of alkane 1, 2, 3, 4, 5 plus Cl2 in the presence of UV light, so you will get like this, right? Okay, because one hydrogen here is substitute with Cl in the propagation step. So because at carbon number 1, 2, 3, 4, 1, 2, 3, 4, 5, so like this. 1, 2, 3, 4, 5, 5. So 1, 2, 3, 4, 5. So here at straight chain it should be 5 carbon. So for Cl, it attached to carbon number. Here should be carbon number 1. 1, 2, 3, 4, 5. So Cl attached at carbon number 1 because at carbon number 1, one hydrogen here is substitute with Cl. So normally at carbon number normally at the place when the hydrogen substitute with Cl, so this carbon produce radical like this. 1, 2, 3, 4, 5 radical like this. So for the stability of the radical, if you want to talk about the stability, okay, if you want to talk about stability, stability, it involves the formation of the radical. So normally tertiary radical is more stable compared to secondary radical compared to primary radical. So how do you know this that carbon is representing tertiary, secondary or primary radical? So here is when the hydrogen lost from this structure, it will radical will be here. So this carbon is representing secondary tertiary carbon. So of course this radical is representing tertiary radical. So what is the secondary radical? The secondary radical should be here, when one hydrogen here is lost. So how about primary radical? Primary radical is here. One hydrogen here is lost, so it will form radical. Normally the stability relate with tertiary, the most stability one, and the less stability is primary radical. So that when I state this answer should be when the Cl attached at tertiary radical here, so it will form major, plus when the Cl attached at here, it will be minor, or the last one, maybe it will attach here, 1 2 3 4 5. So yeah, this one also be minor. Okay, and for question D, suggest how to synthesize compound B from suitable Grignard reagent. So to get compound B from Grignard reagent, this is referring to method of preparation. Which method do you need to refer? So of course the method is related to preparation of Grignard reagent. Preparation of Grignard reagent normally start from Grignard reagent first. Okay, first is here should be Br, act with magnesium in dry ether, so you get here is MgBr. After that you will remove water in the reaction. So at the end of the reaction, The bond will break here. So it will be cross MgOH Br. Okay.